Hello everyone, today we're going to do a little more programming against Solid Edge using the Solid Edge API and Visual Studio with the VB.NET. So this little application we're going to write today is a headless application, no user interface except the feedback that we see within Solid Edge. The goal of the application is I would like to be able to select a face, maybe a little round cylinder or one of these teeth, and have it go and count up all the faces that are pretty much the same within the model, so I can get a report for how many items there might be. Sometimes when you do a pattern, it can be challenging to get a count because sometimes you can suppress a region of a pattern, which can alter the quantity, things like that. So let's jump back to our little program within Visual Studio. So we have already initialized this to save a little bit of time. And if we go into the project, maybe just for reference here, you can see what type of application it is. It is a Windows Forms application, but there is no form. It's an executable with a startup of submain, like we did with an earlier video. And for visual reference, for my options settings for the strict and compare, things like that. So we don't need that anymore. So let's jump into the main module. So if we look at Solution Explorer, you'll see that we just have this main module. That's where all our code really resides. There is a message filter we'll talk about. So a couple of imports. We're using the interop from NuGet so that we can get references to Solid Edge, and we're pulling in a reference to the constants and the framework so we can get IntelliSense and the document type constants so that we can use those constants. Very straightforward. Declaring some private variables, one for the application like we did earlier, and one for something new here. It's a command. Solid Edge operates on the basis of you start a command, you do some work, and then the command finishes. So it's kind of a head, a body, and a tail. So you can create your own command in code. Very cool. And we need some mouse interaction. We need to be able to highlight a face and know when the mouse clicked on the face so that we can then go and count up all the faces. So that we're going to utilize the mouse object through the Solid Edge framework library. And I'd like to show the user by highlighting all the faces that match. So we're going to utilize highlight sets. That's the capability where things just highlight within the program like you saw a second ago when you pass the mouse over. So you can set that highlight set. So you'll see that in a second. So looking at the code, we're going to attach to the running application. And then this message filter is kind of a something you have to do, kind of boilerplate. Because of timing issues between .NET and a COM-based, component object model-based application, there's sometimes timing issues. So essentially, if you run into these, or if you want to read up about this a little bit more, you can go and look on the Microsoft documentation, and if you search for IOLE message filter, which is the interface that the class is based on, you'll find an explanation of why that's necessary. It's used with Office applications quite a bit. So it'll just be better. So you have that at the beginning, and then when you're done, you can revoke. Probably doesn't even need to be revoked because the application is going to end. The executable is going to be done at that point. But it's kind of nice. They should be in a wrapper there. So we're going to get a reference to the active document. Now, I have declared this as object. The bummer is you won't get IntelliSense when you're utilizing it. You could temporarily declare it as a solid edge part document, and then you could get IntelliSense. But because I wanted to work with sheet metal and part, so they're actually two different types. So I'm going to let it fall back to the generic object and let the runtime figure it out. It usually works fine for something simple like this. So I'm going to get a reference to the active document if it's either a part or sheet metal, or else it's going to fall out and exit the sub. We'll get a reference to the highlight sets collection through the document, and then we'll create a command through the running application object. You execute create command, and if you hit the help, you'll see there's some parameters for how long it lives. And we're going to attach a handler so that when the user ends the command by clicking some other command, or he selects in the window, that will also end the command. It will run this terminate, and it'll give you an opportunity to clean up some things. Most importantly, the highlight set that will remain stuck on the model if you don't clear that with remove all. So the faces will remain highlighted until you close the file. It's kind of annoying. So that's why that is important, to have that terminate event. And then we're going to start the command. What's cool about this is it will kind of suspend. It kind of runs in a loop, I would say, is a good way to describe it, in the background. And then it will essentially stop right here when you execute the run method. And that's where it will be looking for interaction from Solid Edge. We're going to set up the mouse. The locate mode means it will highlight faces and not edges, so just faces. I'm sorry, the locate mode is that is a single pick, or using quick pick with a ... So yeah, you can hit the help on the command.mouse to find more details about that. And then the locate filter is here. So this is a way to filter out what the mouse will highlight, and then we're going to wire up a handler, which is an event called mouse down, so that after we go into this run, it's going to just hang there, but it will respond to this event. And this is just the start command will just start the select tool, which is kind of the default command in Solid Edge. So if the mouse didn't land on a graphic, if it just landed in the drawing window, we're just going to make it bail out of this command and go to the select tool. But if it does land on a face, we're going to execute find faces, and we're going to pass into it the graphic handle of the face that it landed on. Not too bad. Little status update so we can tell what's going on as far as the user goes, and we'll just make sure that there is a face. Now, to ensure, what we're going to do is use the area of the face. Now that seems highly reliable at a very high precision, so we're going to compare the selected face to every other face in the model. So I kind of wanted to narrow it down a little bit. So we're going to determine what type of face it is. So if I click on a cylinder, it's going to only look at all other cylinders to find if one matches an area. And if I click on a torus, it's only going to look at all other tori to find one that matches, or a sphere, or a cone, or a plane. So it's kind of a more reliable way to make sure that we have a match. And then we're just going to simply wire up the highlight sets so that we can highlight all the faces that match. So we'll get the area. So we're using the area property of the face, which is the selected face, and we're going to round it down to 7 places. Because of floating point error, I don't think you'll have much luck just comparing the area property, because there'll be minute errors at the least significant digits, and it will almost never match. So you can play with that rounding and see if you find a comfortable place. And then we're going to simply enumerate all the faces and get the area of each one. And if it matches within 7 places, we're going to add it to the select set. Real easy. And then at the end, we're just going to use in order to report to the status bar, instead of putting an incrementer here in the for loop, I could have done that. I just decided to use the count of the highlight set. So I could say how many faces were matched out of the total that were looked through. And then it'll also report the type of the face. The release RCW, this is probably not necessary, but it decrements the reference counter. We can maybe talk about that in another. Really don't think it's necessary here, because this is an out of process executable. It's going to tear down its application domain when it's done. But you can kind of watch the memory within Solid Edge and make sure it's not hanging on to any references. Let's go ahead and hit start. Transition back to Solid Edge, and if we maybe pick one of these little top faces, you see that down here in the prompt bar it's telling us how many it's finding. So it found 4 there. These are B-spline surfaces, and you can use your quick pick. That was the 2 in the so you can see the pause there. I'm not exactly sure why B-spline surfaces take so much longer. I would think the area would be static, but it does seem to take a little bit longer. So that's it. And then when I click in space, you'll see back here that the application is no longer running. So maybe if I jump in again, step into the code, I'll do just an F10. We get the active application, we get the active document, we get a reference to the highlight sets, set up our handler, start the command, attach to the mouse, set some things for the mouse, add the handler for the mouse, inform the user what he should be doing when the command starts, and then we go into the run. And that's when Solid Edge is waiting for us to highlight a face, and then I'm going to go and click a face in Solid Edge and you won't be able to see it. And then I'll go ahead and click away, and you see that now my debugger is continuing on, falling through to the end of the submain, and the program terminates. Well, that's it. I hope this was helpful. Very simple little macro, an example of some of the cool things you can do programming Solid Edge with Visual Studio and Visual Basic.net. Have a good day.